together.
Now, the mouse brain, in terms of evolution principles, is relatively simple. Now, the human brain will be a lot more complex than this. It's a lot more area and a lot more denser area, lighter areas, and so on and so forth. So the Center of Computational Brain Research at IIT Madras is designed in a way where we form the interface between biology and engineering.
Talking about engineering, in spirit, most computers even today rely on the architecture laid out by von Neumann in 1945.
Very good evening to all our attendees from India. Good afternoon to our friends from Europe. And thank you for joining us bright and early to any of our friends joining in from the US, especially the West Coast. Firstly, welcome to the official launch webinar of the IIT Madras Institute of Eminence project and moving towards 100% renewable energy. We'd like to set the stage today by presenting our overarching vision and the steps we intend on spearheading in this very important topic. The agenda for the day includes a presentation by Professor Ashok Jhunjhunwala, followed by a moderated discussion and Q&A. Our moderator for today's event will be Jonathan Fagerstrom from IFA, or the Institute for Energy Technology in Norway. Jonathan joined IFE in 2017 at the Department for Energy System Analysis. Currently, he holds a position as a researcher at the Department for Solar Power Systems. He received his MSc in 2009 and his PhD in 2015 within the field of energy technology at the Department of Applied Physics and Electronics at Umeå University in Sweden. The current research he is focused on is in the hybridization of PV systems in Nordic conditions, and this includes both early phase conceptual designs and control strategies for operation. Thank you, Jonathan, for joining us today. I will now hand it over to you to take us through the day's proceedings.
Thank you, Anderson, for this nice introduction. It's good to be here. So, all right, next up is Professor Ashok Jhunjhunwala. So he's recognized for creating industry-academia interactions. And as an example, he was a Padma Shri awardee. And as an example of his work is that he built IIT Madras, the India's first university-affiliated research park. He got his bachelor degree from IIT Kanpur and master and PhD from University of Maine. He's been back at IIT Madras since 1981, where he leads the telecommunications and computer network group. He currently also sits as the president for IIT Madras Research Park. And now he will give us a concrete overview of how India could go towards 100% renewable energy. So I'm looking forward to this presentation, and the floor is yours, Professor Ashok.
Thank you, Jonathan. What I'll do, I'll share my screen so that we can look at the presentation and get going. This IOE theme is a very ambitious theme. It is focused on India, but focused on taking India to a very important stage, which is important not just for India, but for the world. to take India towards 100% renewable energy. But it's not going to happen quickly. It's going to take decades, maybe several decades, but we need to get there. And this theme is, of course, led by me, but Professor Devendra Jalihal, Professor Jairaj Joseph, Professor Bobby George, Dr. Kaushal Jha, and Anson Sando are working, along with about 30, 35 other youngsters who are actually working to drive this theme. And I'll give you an overview of the theme, what is behind it, and what we need to do. I want to start by pointing out that there is a huge threat for global warming. In fact, we decided on this theme about a year back, but over the last 1 year, almost every day the headlines is about global warming. And the primary cause, if I'm not wrong, is increasing use of fossil fuels. Coal, petrol, diesel, oil, LPG, natural gas, and in all kind of processes. And if you see the graph here, how this has resulted into per capita emissions going up year after year, and this causing the global emissions. Now, if you see the countries like Australia, United States are much, much higher in terms of carbon dioxide emissions. China is also much higher. But if you also notice that some of them are actually moving towards going down. One would say India does not matter because it's so low. But notice that it's only going up. In terms of electricity consumption, India is only 142nd in the world. In terms of per capita carbon dioxide emission, it is 103rd. And therefore, one can make a statement, as is often made by our government, is the onus of reversing global warming is not of developed world, is of developed world, which consume much, much more, and not of the developing countries like ours. India is in developing stage. See, our consumption is so low, and we need to increase our consumption. This is per capita electricity consumption. And you cannot ask us to try to reduce the carbon dioxide emissions or reduce the consumption. But look at another data, a similar data in terms of total greenhouse emission. Of course, here China leads, United States is number 2, and number 3 is India. India is the 3rd largest. Why? Per capita basis is small, but as you take the population of 1.3, 1.35 billion, the numbers multiply. What is worse is that with growing GDP and resulting into higher income, our energy consumption is only likely to grow. It's already growing. For example, GHG emissions has increased by 335% since 1990. No other country has such large increase. Use of air conditioning, for example, most of our homes never had air conditioning some time back. Today, it is already 8%. But with the growing income and with us not able to tolerate heat, it is likely to go to 50% by 2050. So it is a matter of time that we will surpass United States and start matching China. And if with so much of greenhouse emission, if we don't act, we are going to destroy the world, including ourselves. The impact also, by the way, will be most severe on countries like India. So whether we like it or not, we have to act. Now, if you see, where is the problem? First of all, India's total greenhouse gas emission is increasing. If I look at it, our energy source is primarily coal, then crude oil, Electricity, of course, electricity is produced from coal and primarily from coal. So electricity is produced primarily for coal. Industry primarily uses electricity, but also use extensively coal and gas. Cooking is mostly LPG gas and some coal and biomass. Transport uses petrol and diesel. And all this is increasing. And all this are contributor to the greenhouse gas emission. So what do we do? If we look at something else, what is India's problem and what is the situation? For example, the solar electricity in India costs now ₹2 per kilowatt hour. Wind-based, and by the way, rupee is $75 rupees is a dollar, so one can convert. And wind-based electricity is ₹2.50. And coal is also ₹2.50. It goes up all the way up to ₹4. If you take the older plants, which needs more emission control equipment, then you will see it is getting to ₹4. On the other hand, if you take oil and gas plant, it is more than ₹16, more like ₹20 today, or even higher, with the oil price and the petrol price going up. So they are all very high. So one would sort of virtually say, well, solar and wind is the best. Why don't we produce all our electricity from solar? What stops us from converting that? So first question is, do we have enough solar and wind? Fortunately, we have plenty of solar and wind. In fact, a small portion of Rajasthan desert can actually supply all the electricity need, not just today, but by 2030. So we have enough solar and wind in the country. And then we have coastal and ocean wind also. And we have enough for today and tomorrow. I don't know for how long. For the next 10, 15, 20 years at least, we can get 100% from solar and wind. Then where is the bottleneck? The bottleneck is that these are not available 24/7. They're controlled by human beings. Unlike coal, they cannot be controlled by human beings. So unlike coal-based electricity, which can be controlled. So what they need is energy storage. You need to store the energy when there is a surplus solar and wind, and then take it out when there is a demand. That energy storage makes things complex. I want to point out, however, one important thing, that today installed capacity of renewable energy is 25%. Well, one would say that, but 25% is not bad. This is in terms of installed capacity. But look in terms of total electricity generated. Total electricity generated is only 8%. Why? Because solar and wind are available. Maybe solar is about 18 to 20% time. Wind is available around 25% time. So they are not, their average, their capacity utilization factor is only 22%. Whereas for coal plants, one can utilize it as much as 85%. So the real number that matters, very often, it is often talked about 25% of our capacity comes from solar and wind and from renewable. It doesn't really matter. Our energy terms, it is only 8%. 92% is not solar and wind. It's primarily coal and a little bit of hydro, nuclear, natural gas, and oil. That is what the problem is. We have only 8%. So how should it grow? And what does it take to make it grow? So basically, electricity produced must be used instantly, immediately, which means every second you need to match the total generation to total demand, total load. Now, what is the way to do it? Now, 10 years back, we used to do power cuts because we had deficit generation. So therefore, you could cut in some part or another and match that. Now, what do you do when it is surplus? You need to reduce production. That can be done instantaneously for oil and gas, with some delay for coal, but for solar and wind, you don't have that possibility. Another technique that is used is some demand management. Can you get people to postpone use? by maybe incentivizing them to use it when they have low demand and disincentivizing it when there is a high demand. Well, but that gives you only so much of flexibility. The last option is, of course, you convert it to some other form, store it, and then convert it back. What are the methods of conversion? No. Pumped water on hydropower, you pump from lower level to higher level, and then let it again generate electricity. This results into 30 to 35% losses. So we have an excess electricity. You don't operate the hydropower, and you, in fact, operate it in a reverse manner, do that. But there is large losses. Store it in flywheels. How long can you store? Conversion of hydrogen and reconversion to electricity. Definitely a possibility. At current time, very expensive and a lot of losses. The best technique is electrical batteries. Lead acid, lithium ion, solid state, and there are many other batteries very rapidly becoming dominant. And it is a matter of time when you start storing energy, when energy is available, when energy is surplus in the battery. Now in India, all of us use UPS. We store energy in batteries, but that is to use it when there are power cuts. But basically the technique, what is needed is whenever there is a surplus electricity from renewables, store it and then use it. Now, essentially the technique is very simple. Of course, from the AC grid, you need a bidirectional AC to DC conversion, which will convert it to DC electricity. DC, because you need DC to charge any battery, and then you charge batteries. And then you take power out of the battery and again convert it to the AC grid. And you need to do it instantly. You need to be able to increase, decrease that on demand. Now, the biggest concern is the cost of this storage. While the cost of renewable energy is only 2 rupee, 2.50 rupee per kilowatt hour. What is the cost per kilowatt hour for the storage? Well, this is a little more complex and very, very often not understood. First of all, battery is a capital cost. So you need to take the capital cost into account. But it is not that the battery, once you buy it, it will forever be able to store and use it. So you have to ask the question, how many times it can be used? What is called number of charge-discharge cycles. If it can be used 1,000 cycles, and if you do one charge-discharge per day, it will last for about 3 years. Then you have to talk about operation cost, usage cost per cycle. And how many times, as I said, you will charge-discharge per day. If you do it once a day, as I told you, with 1,000 cycles, it will last for 3 years. If you use 1.5 to 2 cycles a day, then it will last for only 1.5 years. Then the next question that you ask, once you store the energy, is there a decay? Is there a decay in 1 or 2 days, in a few hours? Is there a decay in several days? That becomes important. And then what is the end-to-end energy efficiency? Fortunately, for most batteries today, end-to-end energy efficiency exceeds 95%. One can go towards 96, 97, 98%. So that part, it is good. From there, you need to calculate from all these parameters effective cost per kilowatt hour of usage. If I store 1 kilowatt hour of energy and use 1 kilowatt hour later, what is the cost? You have to, because there is a capital cost, you have to use depreciation and interest and add it to the variable cost and then calculate that. That is the cost that will add to the generation cost if I use the stored electricity. There are other costs: environmental impact, toxicity, hazards, recyclability, because many of these batteries have these problems. So you have to really figure that out. Very often it is not even taken into account, but you finally need to take this into account. So how does one cost calculate? So let us assume 70% of the renewable energy generated will be used directly. And that average cost comes down to around 2.50 rupee. And let 30% of the energy goes into the storage. And let a number S be the cost of storing that 1 kilowatt of energy and retrieving it later. So the cost of usage of this 30% electricity through storage is 2 rupee 50 plus S. So this is 30% time, 70% time is 2 rupee 50 paise. So if you calculate average cost per unit, it comes to 2 rupee 50 plus 0.3 S. So I need to compute S, and I know it's 2 rupee 50 plus 0.3 S. Now, if not 30%, if 50% of energy will be through the storage, it will become 2 rupee 50 plus 0.5 into S. And I'll do this exercise for some of the batteries. Now, I have taken two cells which are available in my lab today. I've taken two, say one is a advanced NMC. Now there are normal OMC also, not advanced AMC, but there the cost will come out in much higher. So the one that really works is advanced NMC. It costs about, to make a full battery out of the cell, around 20,000 rupees per kilowatt hour for a large battery, not for a small size battery. And you can do 7,000 cycles of charge and discharge charge. On the other hand, there is another chemistry called LTO, where you can do, where cost is higher, 40,000, but you can do 15,000 cycles, even more. Now, what is the total cost? I will calculate. I have actually included in these numbers the cost of converters also. The interest rate in India is 10%, 11%, 12%. Interest rate in Europe, United States for long term, it could be as low as 2%. So let me do this calculation all the way from 2% to 10%. And surprisingly, this is the result that I get for two kinds of cell. Cell A, which is the NMC, cell B is LTO. And suppose I use it for only one cycle per day. Look, at 2% interest rate, there is not much to choose. You could use LTO battery, you could use the lithium-ion NMC batteries. But if you take 10% interest rate, first of all, your rate goes from 3 to 7 rupees, about 2.5 times. LTO goes up also very high, from 4 rupees to almost 12 rupees. So for countries like India, this is not even a choice. For countries like India, this is the only choice. The reason I'm making a presentation, because very often we hear presentation from Europeans and Americans. They have done their calculation like this, and we go ahead and land up buying this without understanding even the implication. A simple computation. We are so used to just follow the West rather than understanding that in India, 10% is aggressive interest rate. But this is for one cycle per day. What if I do 2 cycles per day? Well, the curve flattens out. It does no longer 7 rupees. This become around 4 rupee 50 paise. It is better at 2 cycles per day. 1.5 will come somewhere in between. Now, what do you mean by 2 cycles? Suppose I'm using solar and wind, and solar gives me at some hours, wind gives me another cycle, and my usage also vary. Can I store, take out, store, and take out? If I can do this, my cost comes down. Why does the cost comes down? Now you look at it, it does come down a bit from around 3 rupee 50 paise. Well, small amount it comes down at 2% interest. But here it comes down to 4 rupee 50 instead of 7. So it's all interest cost. What happens if I take 2 cycles per day? I actually would consume the battery in half the time. The effective interest rate that I will pay is less. So if I finish on the battery, I can actually buy a new battery. And fortunately, since the battery costs are falling every year, when I buy a new battery, it will cost me even less. So in fact, this works out quite well that you can use this. If you use this, it is not advantageous in India. This is not very well understood. But 4 rupee 50 paise also, it's quite high. And 7 rupees, of course, very high. So if I look at it, this is a summary, 7 rupee and 4 rupees, 75% paise. In West, it is 4 rupees. Now, if I now take ₹2.50 for the generation cost plus 0.3 into S. My cost varies from 395 to 460, assuming of course 70% is used directly and 30% through the usage. So it does vary. So around ₹4 per unit is the cost of going through the storage. Actually, it's not bad. So in some sense, to the ₹2 or ₹2.50, it's adding only a ₹1.50 to ₹1 to ₹2 for the storage is adding. That's the average. But let's kind of see what happens. There is another storage. I am sitting in this IIT Madras Research Park. You'll see the picture of that in a little while. This uses 40% of the energy that we use. We use quite a bit of electricity. Today we use 25 megawatt hour a day. Tomorrow we will use 40 megawatt hour a day. And 40% of our energy used is in air conditioning. Now what happens that there is a HVAC system which chills the water at 6 degrees centigrade, and then it circulates the water to each room where it cools the air in a AHU, and then the air is actually pumped to every part of an office. What if I just chill the water and store the water in a insulated tank and use the water later? This is a storage. Of course, the temperature of the water every hour will go up. Roughly goes about 0.5 degrees centigrade per hour in the insulated tank that we have. You could have done better insulation. It could have been better. But even then, 6.5 in 2-3 hours, 4 hours, even 6 hours, it goes to 9 degrees centigrade. But I can still use it. Average loss is only about 5% in this. We have seen this. And so today we have built in at IIT Madras Research Park storage, which in terms of megajoules is 17,460 megajoules, which works out to be 2.45 megawatt hour. So I have that, and that cost is very low. So in India, because most of the places require cooling, we can use lithium-ion battery, plus we can use chilled water battery. It comes out to be much lower than this. Now let's take total cost of renewable energy per kilowatt hour in India. Now, as I pointed out, if I use 30%, my average cost will be around ₹4 per unit. With 50%, cost will be a little higher, maybe ₹5.50. But we can go with 30% renewable energy today, and as the cost of storage drops down in 4 to 5 years, it will become same ₹4. So we don't have to worry about 50% being used. So where can we begin? Now, all this data that I have given you. Now we can of course go to the government, to the grid supplier, please use storage, and they are trying to put it, it needs a lot of capital. Most of these generating stations and power distribution companies are not in good shape, and they're not going to be able to create the storage fast enough. They will wait, and if we wait, we are not going to move to renewable energy. So we have inverted the problem. And we say, can we begin somewhere? And I said, where to begin, but in a commercial complex, office complex. This is the picture of the research park. This is 1.2 million square feet. My average cost of electricity today is 11 rupees. It's actually 10 rupees, but or 9.50 rupees, including the demand charge of ₹50. But occasionally power goes off, and I use diesel. Diesel cost is 22 rupees, 24 rupees, and my average works out to be 11 rupees. So this is the cost today. Can I do something and put it into this? Now, I have, of course, used rooftop solar, but that is only 10 to 15%. Remember that I told you we are using 2.5 megawatt hour, 25 megawatt hour, we probably cannot generate much more than 2.5 megawatt hour from our rooftop. That is at low cost, 3 rupees. So that's tremendous advantage. But unfortunately, I don't have rooftop space. So what else can I do? Well, there is a very interesting policy in India called open access policy. I can help set up a solar and wind generation plant somewhere else, 100 kilometers, 200 kilometers, 300 kilometers from the IIT Madras research campus. And I can wheel that energy using the power transmission and distribution lines that exist today. There is a policy of Government of India that they have to allow me to wheel. Of course, they will charge me, but I'll pay for that transmission and wheeling cost. If I do that, how much does it cost? My solar and wind energy, if I pick up as and where available, it costs around 3 rupees 60 paise per kilowatt hour, higher than 2 rupees 50 paise, because I'm not doing gigawatt hour I'm doing small, maybe 2 megawatt hour for 2 megawatt, 4 megawatt. So, and I'm doing in group captive mode. So my costs are going to be higher. So it will be around 3 rupees 50, 3 rupees 60 paise per kilowatt hour. Transmission and wheeling cost will be 90 paise, plus the discom will charge me, and today they charge me 2 rupees per kilowatt hour. But if I optimize, I can get it to 1 rupee per kilowatt hour. This is a good energy management. Today I'm paying 2 rupees per kilowatt hour. My 9 rupees 50 paise includes, or 10 rupees include 2 rupees is for the what is called demand charges. This is a charge because they have given me connection, they will charge me. So actually, discom and transmission utilities are today will be charging 2 rupees 90 paise, but I believe that I can optimize it. If I have storage, I do not take, they charge on what is called peak demand. I'll reduce the peak demand and my cost will be 1 rupee per kilowatt hour. So my 360 plus 90 plus 1 rupee is what the cost will be. Now, the question is, the problem is solar and wind generated will be whenever it is generated. So I have to actually draw all that. And then if I don't, I have to use it immediately. But I won't be able to use it immediately. So I have to have storage, electricity storage. And which basically mean can office complex like Research Park create, and I need about 10 plus megawatt hour, or 15 megawatt hour lithium ion plus chilled water storage, maybe 20 megawatt hour with bidirectional converter and connect it to the grid. What happens if I do that? My storage cost for 5 megawatt hour will average around 7 rupees per unit. This is, of course, not the chilled water storage. Chilled water storage will cost me less. This is a lithium ion storage. And as I pointed out, if 70% of electricity used directly and 30% through storage, my average cost per kilowatt hour will be 2 rupees 10. And this is something that I'm actually building as a part of IOE project. I can build this so that it cost me in India at Indian interest rate 7 rupees per unit of electricity. Per unit is a kilowatt hour. And as I pointed out, the previous slide, I had to pay 3 rupees 60 paise per generation. For transmission, wheeling, and distribution, I have to pay 90 paise per kilowatt hour. Demand charges, I have to pay 1 rupee. Assuming I have optimized, my average cost will come to 550. Add 550 to 210, and my total cost comes to 760. Let's assume that I have not done calculation very well. Let's assume it's 8 rupees. But 8 rupees is much less than 11 rupees that I pay today. What does it mean? If I decide to do the right thing with good energy management, very good energy management, my building cost will decrease. Of course, I'm not talking it for a pilot plant. Pilot plant cost will be higher, but I'm talking about when I do it at scale. My actual cost of electricity will decrease. And if my actual cost of electricity will decrease, it's a highly profitable for me to do it. Of course, some R&D has to be done and some cost optimization has to be done. Now, if I can do it, I can in future bring down the cost further. Captive cost can be brought down from 3 rupee 50 paise to around 275. Transmission, wheeling and demand charges, can bring it down to below 2 rupees. In fact, 2 rupees is high. And my storage cost also can be brought down, and I can do it at maybe 6 rupee 50 paise. So even at 10% interest rate, and even assuming 50% of electricity is done through that. So it eliminates diesel generator also. Storage pays back in a few years. Now, what does it mean? There are 40,000 such complex. If I can do it, it can be done in 40,000 complex. That's a very, very good beginning. Now, let me look at, and then I can go sector by sector and start becoming more renewable energy, more renewable energy, more renewable energy. It will also give me a brand value for my research plan. Now, the next question that I have to ask as an engineer, which work we are doing in IOE, how much storage does a complex need? Now, I see the India pattern. This is estimated wind energy in different time of the day. Solar is generated during this time. More or less this is, but it varies from day to day. Now, based on that, I can calculate. Of course, this is on a one kind of day. I have to do it for whole year, and I'll get different pattern. And based on that, I will say I need this kind much of storage, which basically means that I can store it any time of the day and use it any time of the day. In fact, use it for 2-3 days also. That is a short-term storage, and there is no problem with the chilled water and lithium ion. Whatever I've just presented can actually be done. But India has, and we will have another problem. This is the long term. Look at the long-term renewable energy supply, and this is the India number throughout the year. If you see solar is more or less constant, it does dip a bit in January, February, but more or less constant. A drip during monsoon time, but more or less constant. But not so with solar. Not so with wind. In India, the wind is low for several months and then go very high for some months and then again goes low. So this is a big problem. I need a long-term storage. I need to store during these months, during June, July, August, September, and use it in January. It requires a long-term storage. What do I do? Whatever I had presented with lithium-ion battery and chilled water storage cannot be used. What are the options? Well, this is where things get difficult. Pumped hydro can be a storage. If there is a way by which I can pump up the water and then use it, pump up the water during these times and use it in other times. Well, it's not so easy because these are time also the rain is very high. So I'll have a problem. Compressed air storage, well, we don't know where the technology is. Hydrogen storage, still very, very expensive. Need very aggressive R&D to reduce cost. Batteries are not suitable. And this is a challenge. So a third energy source will help. Can hydro be another third energy source for India? Problem with hydro is, in India, most of the hydro plants that we have set up over the last 60 years are starting to silt and producing less and less electricity. And starting to cause a lot of environmental damage. Any new hydro plant we try to set up, it creates a huge environmental havoc. We have seen the kind of things that we can do. We cannot go fast on this. India is not capable of generating large hydro. Can we convert biomass to electricity? Well, 10% of our renewable energy today is coming from biomass. But costs are very high. We need R&D to reduce costs and figure out what percentage can we do. It will help, but we have to also understand what kind of emissions they do, etc., etc. Fortunately, some of my colleagues have pointed out at IIT, there are other battery chemistries like zinc-made metal or aluminum airflow battery. Maybe these could be used. So what we need to do, while we build things with lithium-ion batteries, because they're available today, we need R&D on zinc metal, in aluminum airflow, so that in a few years' time, and in our IOE project, we'll at least watch this. We won't be able to do aggressive work in this, but we like to do. We like to partner with some European or some other American institutes which is working on things like this. Can ocean waves be a fourth source of energy, third source of energy? Now, Nordic region, ocean wave, a lot of work has been done. But even there, large plants have not been set up. And when I look at the coast area around India, there's huge coast. The ocean waves are not as strong as Nordic region. And the existing techniques are not good enough for generating electricity from small ocean waves. But this is an area that we need to work on. Can we come with a totally different way of using the ocean energy and make it a third source of? Can we use small modular nuclear reactors? A lot of talk is going around in the world. This is a somewhat long term. Maybe it will give us result in 15 years, but we need to watch and start working. These are the new areas that we need to work on besides solar and wind for renewable. What about for storage? Storage, I've already pointed out what we need to work on, particularly hydrogen storage. I've also pointed out zinc, metal and aluminum airflow. If we can do with something with pumped hydro or compressed air, these are the areas that we need to work on. There is yet another area that we plan to tackle in IOE. And we again shall say, research park is an ideal place because it's a commercial building. We use a lot of air conditioning. Can we enhance the energy efficiency? Now, what happens if I enhance the energy efficiency? My consumption of electricity goes down. If my consumption of electricity goes down, my greenhouse emission goes down. And air conditioning, India will become a very large consumer of air conditioning. So can I make air conditioning very efficient? So as I told you, from 8%, it's going to rise up to 15%. And there is a huge work going on that energy efficiency can save huge amount of carbon dioxide emissions. IIT MRP, as I pointed out, is already using 40%. And if we can increase energy efficiency. And this is the work that we are doing. We are doing all kinds of work with air conditioner by automating the air conditioner to start giving the chilled air only where it is needed in a small part of office. If I am sitting only near where I am sitting, not in other parts of office, controlling it and giving to each person what they need. Can we save the watts per square feet? And we have seen that the work that we have done, and this gives you an example that with automation, we are able to very significantly reduce the watts per square feet from 13 watts per square feet to as low as 5.76 or 6.01 watts per square feet. The third area that we need to work is electric vehicles, because our transport fuel is petrol and diesel. We cannot continue and it is the biggest polluter, whether we like it or not, it is the biggest polluter. I have a good article in IEEE Electrification magazine, which I can give reference. By the way, if any one of you need the slides, you have to write an email to me and I'll share the slides with you. Electric vehicles, why is there so much interest? 14 of the 20 most polluted cities in the world are in India. And India's petrol bill is going up year after year. Our oil dependency is going up more and more. On the other hand, electric vehicle is 4 times as energy efficient. Energy efficiency for full ICE vehicle is about 22 to 23%. And for the EV, it is about 90%. So how fast can we move there? If I look at it, affordability is a major factor. And this is a big bottleneck for us to switch to electric vehicles. But if you notice this, 79% of our vehicles are two-wheelers, 5% are autos, and a low-cost car, less than ₹1 million, is 11.5%. So this is the area where we can really make a difference. We can become the leader in this. Another area where a lot of work is going on is battery swapping, particularly for small vehicles. Batteries dominate the cost of electric vehicles. So, but purchase of vehicles without battery costs less than the petrol. So can charged batteries be rented out and swapped? You use that, and whenever you run out of the battery, you take a swap battery and return your discharge battery. It has all kinds of advantage. Now one will say, no, it's a very, very tedious process. Remember, we don't use piped gas, LPG gas in the country. We use LPG gas cylinders. 20, 30 years back, 40 years back, when we started, people sort of said, oh, this LPG gas cylinder will never work. We should put pipes in every home. Now, those of us who live in India understand we can't even pipe our water properly. If we would have started putting pipe, we would have never reached everywhere. Most of the homes wouldn't have been covered. Today, even the rural areas are being covered with LPG gas cylinder. So this battery swapping is a very, very good technique. The next question that sometimes doubts are raised, it will hurt our GDP because 7% of our GDP comes from autos and 5% of our GDP comes from fuel refining and distribution. You'll hurt them 12%. The point that I will make, EVs may contribute equally or more to GDP to the job if we start worrying about and making everything or battery materials by recycling the old batteries. We make the battery cells here, battery packs here, motors and controllers here, chargers here, vehicle controllers, converters, and vehicle accessories here. We make this that will contribute more than 12%. Of course, if we import all these things and import it from China, it is China's GDP will go up. If you import it from somewhere else, their GDP will go up. So this is a challenge. And our work, IOE is supporting our project on 100% renewable energy, is supporting this kind of work. We are even working on lithium-ion battery materials. We are working on battery cells, battery pack design, motors. I will not get into details of this. Everywhere, India needs unique things because we need affordability, we need recycling, etc., etc. And this is what India can do, and our group under IOE is supporting to this. We are also working on vehicle to grid. By the way, this was the idea that came from Jonathan. Can we, in the daytime, when electric vehicles are parked here, can I charge the vehicles? And when I go back to my home, can my vehicle supply electricity to homes in the evening? Remember, it is the evening time I consume most of the electricity. Can we try something like this? We are working on something like this. We are also working on a very interesting desktop electricity dashboard, which actually starts putting all the data about India, what is happening, what is not happening, where things are needed. We are actually creating this dashboard out of this IOE project. And then we have started working on policy initiative. The policy initiative could be towards 100% renewable energy. What should be the government policy? How should the transition be encouraged? How should economically viability should be encouraged? We are working on the policies for this. We are asking open access electricity for wider access to renewable energy should be promoted. We are working on how to improve energy efficiency and promote electric vehicles. At the same time, as we pursue 100% energy, our objective is first to do it in commercial complex like this, then to do it in industry, then to do it in large urban housing, multi-storied urban housing. And gradually you'll find that almost 60-70% we already will be renewable. And we should move to 50% renewable energy in a decade, and then we could move higher and higher. And of course, we should also enhance the energy efficiency of air conditioning and heat pumps. We at the same time needs aggressive R&D. The work that we are doing is 2 years plus next 3 years. So its impact has to be felt immediately. Longer terms are work on other battery chemistries, particularly look for zinc metal, aluminum foam. We have to bring it down hydrogen generation, storage, and usage cost down. Today it is astronomical, 6 to 10 times as high as battery cost. We need to look at generation using biomass, look at small ocean waves, small modular nuclear reactor. We need to look at pumped hydro and compressed air. This is the kind of work that will be needed, and R&D and all this needs to be promoted, because some of this will give us result today. Some of this R&D will give us result, start giving result 5 to 10 years down the line, and 10 to 15 years down the line, and 15 to 20 years down the line. We need to have a full plan and do this in a manner saying that we will do it because we need to do it. There is no option for us. Thank you very much. With this, I'll stop and maybe take question answer. I'll stop sharing, but I want to just show once before I stop sharing my email ID in case you people do not have it. ashok@tenet.res.in. This is my email ID, and please feel free to write to me if you want the slide or any other question. But I'll stop here and hand it over to Jonathan.
Thank you, Professor Ashok. That was very interesting, and I liked your concrete way of presenting this with calculations, with costs, and also directly for your research park and what it would mean for you. So it's good to have a starting point. There are several questions in the Q&A, and I have a few questions as well. So I will jump into these questions. First, you mentioned both wheeled in energy, but also locally produced PV. So do you believe there is a limit of, did you say 10 to 15% local PV, or what are the barriers? How high do you think you could go at your research park when it comes to locally produced PV?
Today, we can go only about 10 to 15% because my space in the rooftop is limited. I've already covered it. And I'm assuming 18% photovoltaic efficiency. If photovoltaic efficiency increases, I may be able to produce. But then from 10 to %, I can go to 15%, not much higher.
Yeah. Have you, in Norway, it's getting more popular with building integrated PV. So on walls, for example, do you have any good locations to use other surfaces than roofs?
There are some, but I think it will not add to substantial, not more than 2-3%. So I think, as I pointed out today, it's about 10%, we can go to 15%.
Yeah, okay. And then you mentioned also the EMS, energy management system, and you emphasized the importance of having a good EMS. So what do you see as the most important functionality of this EMS in your research park?
The two most important thing is we'll get solar and wind as and when available once we wheel in energy. We need to use whatever we can and store whatever we cannot immediately. And then if you have deficit, when we don't get enough solar and wind, we need to get it from the storage. So storage management, understanding what solar and wind is generated to now and what is likely to be generated, what is a demand pattern, I need to really optimize my storage. And I have two storage, one chilled water storage, another is a lithium ion storage. Chilled water storage, remember, the temperature goes up as I store for longer hours. So I can use it for only a few hours. So I have to actually match all these things in a very, very careful manner. So that is the first work of matching that. Number two, it actually enables me to get energy efficiency. Where is the consumption taking place? What kind of consumption? What is the pattern of that consumption? Do I understand that and predict and use it for my storage? Can I reduce? Is the energy being wasted? Can I reduce it any places? Can I even involve my consumers, my users, my people who are working in the research park to try to not use excess energy? Can I and use it when more energy is available? Can I help them postpone the energy usage? So all this will become another kind of thing that work can be done. A third kind of work, many of these offices, large offices, they put their own storage. And in which case, optimizing multiple storage. So the energy management and storage is a very, very large portfolio. I also need to manage the generation, where it is generated, the transmission of that the losses are minimized, and I get most of my electricity. So this is the energy management and distribution work, management work.
A related question from the audience was also how AI could be related to forecasting and EMS and so.
So AI can certainly be used for forecasting. If I have a better forecast, my management will improve. My storage size will go down. Storage size goes down, my cost comes down. So that is another thing that one can do as we go to multiple sites. As I told you, 40,000 commercial complexes itself, then all the schools and colleges, then go to industries, then go to housing complex. I think AI will play an important role.
I think that is a very good comment and something we have seen here in Norway as well, that if you have a good EMS, you can actually buy a lower storage system, which will make it more profitable. So having a good forecast is definitely really important. Then one question of the batteries. You mentioned you have an advanced NMC, and you have also some LTO tests. Have you been looking at the LFP battery from your side?
We have. The number of cycles are not good enough. The costs will come out very high. Also, the point is LFP battery are 150 watt-hour per kg. There is nothing better than that. And apparently it has reached its theoretical limit. So it doesn't have a future life. So whereas if I use a battery and 5 years down the line, I replace, lithium-ion battery cost will come down by a factor of 2. The LFP battery will not come down.
Okay. Then I'm thinking about, you mentioned these other third renewable energy sources. Have you seen any activities in India related to hybrid power plants? When you combine, for example, solar wind, solar hydro, and have those in one setting?
So when we are talking about storage and putting everything on the grid, is like combining everything. So there are some plants which also combine, which may at the point of generation itself can give me a more even electricity. But those are different techniques that can be used. But I'm taking all my solar all over India, all my wind, all my hydro. Even there, the issues become a strong issue. So I'm actually talking about on the demand side storage, which is very much in our hand, and it makes things profitable for us.
Okay. Then there are some questions, many of them. Many people mention ocean waves, for example. You had this in your presentation. Do you think, so you had many examples. Do you think one of these that you mentioned is better suited or not?
I think hydrogen will happen. Hydrogen, because there is an interest all over the world. And we need to do it because our costs are even lower. So our interest rates are higher. Very often, even most people don't even compute with our high interest rate. So if the one-time cost in hydrogen is high, it won't help us. So we need to aggressively do R&D. Unfortunately, the R&D that I've seen in India does not take economics into account. And today, cost of hydrogen storage will be 100 rupees per kilowatt hour, as opposed to lithium-ion batteries, 7 rupees per kilowatt hour. But I think we need to pursue aggressively. I hope in 7 years or so, we get there. In terms of ocean waves, as I pointed out, I was disappointed. I thought that we could do something. But today, from our small ocean waves, even the techniques have not really been developed. So, but I'm sure there are lots of new techniques, a lot of new way of thinking has to emerge. How do I leverage ocean waves? Nuclear, I think we need to watch out. There is small nuclear plants, safe, people are saying, almost tabletop kind of nuclear plants. I think we need to not ignore this because India doesn't have that much of hydro. So for all the reasons, we need to watch out on nuclear. Then I've already pointed out that there are other batteries. For example, I do see zinc and aluminum for long-term storage. Very important. That we should really look at.
Okay, yeah, there are definitely many possibilities and we should not restrict any, just let the research go and see what comes out of this. We have so many questions in
Can I go through? I can see some of those questions. Can I run through?
Yeah, of course.
There is a question about hydrogen, which I just answered from Selvam, Kalimuthu Selvam. Prasant Singh is asking me questions on plastic. I do not know. Somebody else have to find the answers tomorrow. About Saeed is asking me question on does wheeling charges depend on distance? It does depend on distance, but the 90 paise that I took upon was for certain distance. It varies from 80 to 1 rupee. It won't vary too much. But yes, if you take it from very long distance, cost may go up. So distribution dominates the cost. How much can we improve OTEC efficiency? What is OTEC? I don't even know. Does anyone know what OTEC is? I don't know. I can't answer the question. What is your view on infinite amount of energy? Is there any research going on infinite? I don't understand the concept of infinite amount of energy. From our point of view, of course, solar looks like infinite. But I don't understand the concept. Why is it difficult to introduce ground power generation of electricity? Ground, you mean to say that using the, what is it called? From the underground, the temperature difference, using the temperature difference in the underground. I think there is some research going on. I don't know much about it. The thermal differences between ground and different level. Geothermal. I don't know much about it, but doesn't, as of now, it's not something a short-term thing. Pumped energy storage, I think, can be, somebody has said, can I pump water on the top of my building, tall building, and can I pump it down? I think a good area of research. I'll ask Dr. Kaushal to examine that. I don't know. How much can I recover? Good area of research. If I can do it on buildings, yes. But of course, I have to create a large water storage on the rooftop and on the ground floor, on the floor. But maybe something can be done. I don't have numbers. Plastic is a major reason for increasing global warming. Sure, it's a use of, again, oil and other things that we need to worry about anyway. Why do India, new questions are coming, so I'm not able to list a question. Why India is not giving that much importance to producing electricity from ocean waves? I told you that it's a very low, small ocean waves. We should do more work. I have not seen good work. Why do electrochemical batteries get dominant rapidly? Today, the cost has becoming very, very low. I presented that in my talk. Success of pumped water storage is not high. Somebody is making a comment. How much feasible is the fusion energy? I think we don't know. We should keep looking at it. But I'll say even fission energy, small nuclear plants is something that we need to watch out. Is supercapacitor a battery? It is a battery, very expensive. It's actually very fast charging and discharging. But in terms of capacity, it's very, very expensive. What is the role of biodiesel? Well, biodiesel is after all again fossil fuel. Well, no. But biodiesel does get generated, but it's still emission is a problem. And I don't think the cost is, its efficiency, as I told you, is like petrol, 4 times less than the electric motors and all that. So finally, we are back to that same issue. Can graphene influence the cost? I see people are. I'm not able to see. Where use superconductor in India? Is it possible to make energy from RF waves? No, I don't think RF waves will give us enough energy. We are talking about solid energy. So I can't see more. Can graphene influence the renewable? Graphene plays a very important role in many, many subsystems. It could also play a role in batteries. I've seen some work. I'm not very familiar with that. Okay. Any other questions?
I think you definitely made a good job of sparking the interest of the audience with so many questions. So I'll wrap up with this last question here to you, Professor Ashok. And I'm really eager to get more experience and learn from your site at IIT Madras. So when do you think you will have more data and analysis of how the project is going?
We are moving very rapidly. On the one hand, we are building the storage, both lithium ion and chilled water. On the other hand, we are trying to wheel in electricity. In the meantime, Anson will keep you informed. We want a strong tie-up with your institute. We have a lot to learn. Look out for zinc, aluminum, and aluminum airflow battery. If there is some work going on, we'll be very interested. We need to establish very strong tie-up. We tried to do this through an Indo-Euro project. It didn't happen, but I think we should do a MOU straight away and start working on it.
I agree.
We are also trying to do a tie-up with some UK universities and some French university. I think we should do that. There is a lot of areas where work is needed if you want to get to 100% renewable energy. Remember, India has no other option. We have to get there, and any help that we can get in with our R&D will get there. But we are committed to it. In this IOV project, we'll make a difference. Thank you. Thank you very much.
Very good. Okay, thank you, Professor Ashok. I'll leave it over to the organizers to wrap this up.
I am again typing my email ID in the chat if anybody needs it, and I'll be able to send you the presentation. Thank you.
Thank you. Thank you. I extend my gratitude to Professor Ashok for this absolutely amazing session. Thank you for taking time out from your really busy schedule and for.
Could you understand what I said?
Yes, I did. I was
my job
out of it.
Then my job is done.
Yeah. So, thank you, and for talking to us about your absolutely incredible research initiative. And I'm sure every participant, all 300 odd, all of us at the webinar today was really inspired and is also earnestly wishing you success. So thank you so much, sir, for talking to us and explaining everything in such detail, and it was absolutely interesting. A special thank you to Dr. Jonathan for moderating the session. We're really glad that you could be a part of our webinar today. Also, thank you to Anson and Dr. Kaushal for being part of the webinar, and special thank you to Anson for helping organize everything. So yeah, thanks to all the participants for being with us today. Thank you so much. Good night.
Thank you very much.
Thank you, Ritu.
Thank you.
Okay, bye-bye.
Bye.
Bye.
So one or two corrections we need to do.